hope you all are fine. I'm Natasha and welcome back. So today we're gonna continue in our chapter 1, and that is sets. So in the previous video we did something related to subsets topic, isn't it? Yeah, we actually discussed about subsets. Yeah. So in this video we're gonna continue after the subset topic. Okay, so let's get started. Okay, so first what are we gonna do? So sets. So today's first topic is gonna be about the subsets of sets of real numbers. So we do have real numbers and they are also subsets. So the subset of sets of real numbers. So this is gonna be our first topic. Okay, so let me write it in the board. So this is gonna be the main heading. Yeah. So subsets of the sets of real numbers. Okay? Of real numbers. Subsets of the sets of real numbers. Okay, so we have a lot of sets of real numbers. Like we can say sets of natural numbers. So the set of natural number is going to be our capital N. So I'll say that set N is equals to the elements 1, 2, 3, 4, and 5, and so on. You'll go to infinity. So this the set is written, so this is going to be in roster form, or we can say tabular form. And which type of set is it? So I'll say that this is infinite set, isn't it? So because it will go to infinity, we don't know that where it is going to end. So the set of natural numbers, n is equal to the elements 1, 2, 3, 4, 5, and so on. So this is the first set of real numbers. It comes in real numbers. So second is gonna be the set of integers. Yeah, it's common, integers. So for which I'm gonna represent it. So I'm just gonna represent it from z. Okay. So z is equals to the elements ... -2, -1, 0, 1, 2, 3, and so on. So this is also in the roster form, and it is the type of, it is an infinite set. Okay, so it is also infinite set, and so now the next is gonna be the set of rational numbers. The set of rational numbers. Okay, so we're going to have a look at the subsets of the set of real numbers. So that's what we are doing. So set of rational numbers, I'm going to represent it by Q is equals to, okay, let's take it a little bit different, okay? So X is going to be, X is equals to P upon Q, where P and Q, or maybe I'm going to use comma. Yeah. So P comma Q belongs to real number. Oh, sorry, yeah. Actually, P and Q belongs to integers. And one more thing is that Q is not equal to 0. Just have a look. So we have the third one, the set of rational numbers in set builder form, and so it is X, which is equal to P upon Q, and P and Q belongs to Z, which means these two elements are integers, and Q is not equal to 0. Okay, So yeah, and I'm gonna use int here, so that would be like more better than using comma. Int. Okay, and yeah, one more thing is that I forgot to write here x. So you know where set q is equals to the set of all x, such that x is equals to p upon q, comma q belongs to z, and q isn't equal to 0. This is the correct formation. Okay, so let's first of all find the elements. What exactly the elements are going to be. So it is in set builder form, so let's write it in roster form. Okay, so it is saying that we have p upon q. We have p upon q, and q isn't equal to 0. So we can say it like we can use any number, but it's in the denominator we should have 1, 2, 3, but not 0. Okay, so I'm going to say that the elements are going to be 5 upon 2, 3 upon 2, and 7 upon 3, and 11 upon 5. Okay, just have a look at the elements. Okay, just have a look. Okay, so I hope yeah. So actually one thing is that we can use any number we want. I can write this one, or I can also write the second, which is going to be -5. I'm also using the negative integers also. So -5 upon 1, which will say it, and 5 upon 7. It can be anything. And let's say 3:1 upon 2, which I'll say is 2 3 is 6, 7 upon 2. And the final one we have is going to be 11 upon 3, -11 upon 3, okay? Because this is -3, so the negative sign is going to go in up, in numerator, so we're going to get -11 upon 3. So just have a look. We can write any element we want. So, is that it? So, that's it, so we can write any element, but yeah, one thing we have to remember is that the denominator shouldn't be 0. We can use 1, 2, 3, 4, 5, or -4, or -3, -2, -1, whatever. Okay, just like I can say in this case, but this is going to be actually -5. And so this is -5, which if there's nothing in the denominator, like we have -5. So if there's nothing in the denominator, so we can add 1. This is like really common, so I don't need to tell it. Okay, so now we have some set of irrational numbers. Okay, this is going to be the main thing. This is going to be the interesting part of this topic. So as you can see, there are a lot of substance. Sorry. Oh, I'm just saying that there are a lot of subsets. I was saying subset, but it isn't. This is subset. So there are a lot of important subsets of R, set R, which is going to be real numbers. So I'm talking about the set of irrational numbers. So set of irrational numbers is going to be, okay, let's represent it by T. And one thing is that, okay, so we have T as the set of irrational numbers. Just have a look. So what elements are going to be in our set T? So yeah, I'm just going to say that the set T is composed of all other real numbers. So I can take any element I want. But yeah, this one thing is that going to be the elements will be. So I'll write the elements are. I can say it's going to be under root 2, root 5, root 3 any. You already know that in irrational numbers, we're always going to use under root because it's going to be like, if I'm going to write 3 is to 1 upon 2, which I can also write as under root 3. So you all know that. So, irrational numbers, we're going to not write them in the fraction form. So we're going to use, we're going to write them in square root, under root. Yeah, so I can say under root 2, root 5, root 3, and maybe pi. Do you know pi? I think you all know. So it can be any element among these. So I've told you. So one thing here you've noticed, these all are the subsets. These all are the important subsets of set R, which is the set of real numbers. Got it? So one thing if you have noticed, but I've noticed, I don't know, maybe you've noticed, but it is that the n is the subset of Z, and Z is the subset of Q, and Q is the subset of what? So I can all say that it is making a small pattern. Now let me just tell you what pattern is it making. So first you have to guess that what pattern is it making. Okay? Okay, so let me continue. So n is a subset of Z, you can see. Okay, so 1, 2, 3, 4, 5 are all the integers. They're all integers, so I can say that n is a subset of Z. And Z is the subset of rational numbers. You can also see in it. And one more thing is that Q is a subset of real number. Have a look, isn't it? Because these all are actually the subsets of real number. And one more thing is that set of irrational numbers are also going to be, so I'm going to say that set T is a subset of set R. But one thing I've noticed that N is not a subset of T. Have a look. Is it correct? Of course it is, because you can see the natural numbers. The natural numbers we have 1, 2, 3, 4, 5. But in irrational numbers we don't have any of them. So we can say that N is not a subset of course, set T. Okay, so this was a small pattern we can see in the subsets of sets of real numbers. So now let's move on to our next topic, which is going to be about intervals. Oh, this is an interesting thing. And so we're going to have a lot of fun. So let me just roll up the board and then we're going to continue. Okay. Not again. Yeah, so I'm done and let's continue. So in the previous, I just told you a pattern, in the previous topic. So that was actually a relation. I can say the pattern and the relation among all those sets. So let's continue. So our next topic is going to be the intervals. Intervals of subsets of real numbers. So what I'm going to write is our next topic is going to be about the intervals of subsets of R, of real number. Have a look. Intervals as subsets of R. Intervals as subsets of R. Okay? Intervals as, oops, sorry. It is as, not of. Yeah, this is going to be correct. So intervals as subsets of R, real numbers. So let's have a look. First, we need to understand everything about intervals. You know, what are intervals in math? So how are they useful to us in sets? And what do they provide us? So that's all we are going to discuss. So first question is that what are intervals? So intervals are actually, you know, they're used in sets too. So intervals is, let me just take a small example so that you can understand it. Okay, so I'm going to say that let element A and B, have a look. Let element A and B belongs to real number, and A is smaller than B. Okay, just take it in your mind that A is smaller than B. So I can say that whatever the value of A is going to be, it is going to be greater than B. Okay, so we don't have to find the values. We're just, you know, taking examples. So okay, so we have two elements in our set R, that is A and B, and A is smaller than, A is smaller than B. Oh, sorry, I said wrong. Actually, A is smaller than B, which means that the A is going to be smaller than B. Okay, so whatever, I'm going to just, you know, replace them. Okay, so yeah. So the B, whatever the value of B is going to be, it is going to be greater than A. Yeah, this is correct. A is smaller than B. So this means that B is greater than A, not A is greater than B, okay? No, it is not. Okay, so I can say that A is smaller than B. Yeah, I can say this. So let's continue. So we have two elements in our set R. So what are we going to do? So the set of real numbers, we can write it like in set builder form. So I'm going to write it like that. We have Y, which is, we have Y, and Y is, in Y we have X, and X is actually smaller than X, and X is smaller than B. Got it? Just have a look. Okay? Is it clear? Yeah. So, actually I've used X, so I'll change it slowly to X. And if I write A, or whatever I'm gonna write here, it's gonna be right here. So, what if we have to find the value between those two points? So that's what intervals are used for. So let's first of all understand about this thing, then we're gonna discuss about intervals, okay, in detail. Okay, so X is equals to A. So, is not equal to, so X such that A is smaller than X, but X is smaller than B. So this means that B is the greatest of all, and X is greater than A, and B is greater than both X and A. Got it? So we have two intervals. You know, basically we have first one we have is a open interval. Okay? Open interval. And the second one we have is closed interval. Closed interval. So in closed intervals we use these big brackets, and in open intervals we use these normal brackets. So these normal brackets means exclude. You know, in these big brackets is going to be include. Okay, so and yeah, one more thing is that if it's going to be like this form, this is going to be, actually you can say it as a list, but no, we're not going to talk about this one. We're only going to talk about the open interval and a closed interval. So this means include, and this is going to be exclude. So we can have some following types of intervals, but before that, let's understand that what are intervals. So let me just take the camera on focus or not. Okay, so it's super clear, and let's continue. Yeah, so now our intervals topic. So first is that what are intervals? So actually interval is a set of real numbers that contains all real numbers lying between any two numbers of the set. That's why I use this examples just to tell the value between these two elements, I can say, or whatever. So I hope you all have understood that intervals is a set of real numbers that contains all real numbers lying between any two numbers of the set. Got it? So our next thing is going to be that how intervals are useful to us. So how are intervals useful to us? So they're useful in many ways. Like they're useful when we're describing domain and range. So domain and range, we're going to study about them in our next chapter. That is going to be relations and functions. Okay, so this is include and this is exclude. So why did I tell you this? Because we're going to use this in our next topic, or next I'm going to say in the next section. Yeah, I'm going to say next section. Okay, so this is the first one. Yeah, so I can say that we can use intervals to show that a value falls between the two endpoints. So we can use the interval notation to show that a value falls between the two endpoints. Like we have, I can say that A and B. So in this form, in open interval. So in open interval, we have this form. So I'll say that in open intervals, I'm going to write A, B. So this is an open interval, and in a figure form. In figure form, it's going to be like, yeah, let me show you like this way. This is going to be the easiest way, I think. Okay. And a closed interval, which is going to be in A, comma, B. Okay. So, closed interval. Okay, so if we have closed intervals, this means we're going to use square brackets, these big brackets. And if we have open interval, so we're going to use normal brackets, which we usually use. So the figure is going to be like this way, A and B. Okay, and in this one we have something like this. Okay, I'm showing you A and B. Just have a look. Okay, so you can see something different now, and that is in open interval we have A. So in A it is blank. So we can say that if it's blank, which means that this is an open interval from this side, and in the other. And if it is, if it's filled, then, we can just simply say it's a closed interval. So this means that we're going to use these square brackets. Okay. So, these big brackets. So now I'm going to talk about exclude and include. So one interesting thing we have is that intervals can be also like any other way. Now let me tell you that how they can be. Okay. So the interval which contains the endpoint is also called closed interval. So I can say that these intervals which contain endpoints, I'm just basically going to say them closed intervals. Got it? And the next one we have is, I'm talking about another type of in sets. So let's continue. So we can also have intervals closed at one end and open at other. So we can have also closed at one end and open at other. Really, it can happen. So that's why we use exclude and include. So let me just show you. Okay, so first one we'll have is going to be in this condition. A, comma, B. So what I'm going to say is that the open interval is from A to B, comma, including B, but excluding A. Have a look. So it is saying that the open interval we have is from A to B, and it is including B but excluding A. Got it? So you can see through this. So this means it includes. So you can see in the first we have, oops, wait a second. Okay. So have a look again. I hope it is clear to you. Okay, so the open interval is from A to B, including B, but excluding A. Got it? I think so. Okay, so one thing we're gonna see is that, all of us are confused in exclude and include. So actually, this one is right, but this is, I've just replaced them. So actually, the big brackets is gonna actually exclude them, because I've just told you, right, the definition, for closed intervals, the end points, the end point. So this is gonna be actually exclude, okay, and this is gonna be include. So let me exchange it. So this is going to be what? This is going to be include. Oops, exclude. And this is going to be include. Now this is going to be right. Exactly right. Include. Okay. This is right. So in the first we have, so in the set builder form we'll have it like this way. X such that A is smaller than X, and X is smaller or equal to B. Okay, and yeah, one more thing is that we're going to use, our braces. Okay, have a look. So you can also, just guess it by, these symbols. So we're gonna do some practice questions in which we're gonna find out that is that an open interval or closed interval through these symbols, okay? So mainly if we have a smaller or equal or greater or equal, this means that it is usually used for closed intervals. But if we have normal, like greater or smaller, whatever we have, this is going to be simply in the open intervals. Got it? And this is going to be closed. We can say that. And so the next case we have is going to be this one. And let me show you in a figure form. So it's going to be like this way. Make a line, and I'm going to make these two dots. And I'm going to fill the last one. So I can say that this one is A and this one is B. So you can also see that it is including B but excluding A. It's really clear. Let's have a look, and I'm rubbing the thing which I just written. Okay? I think it is clear to you. Okay, including B but excluding A. I'm going to rub this one. Okay, so the next one we will have is going to be, remember in the open we have a blank, but in the closed we're going to just fill it, so that's, I just use it in a figure form. So, yeah. So our next is going to be this one. Close and open. So we usually say them half closed interval, and this one also half closed interval. Yeah, we say them. So in this case, we had the open interval So it is an open interval from, the open interval is from A to B once again, but there's something is that it's including A, it's it's including A but excluding B. Got it? Have a look. Is it correct? So from A to B, it's including A but excluding B. Got it? Okay, so let's continue. Yeah, so I was saying that it is the open interval is from A to B, including A but excluding B. So I have like a little bit of confusion, so let me just clear it. So it is like open interval is from A to B. So it's A to B, including A, which is going to be the open interval, and including including B, which is, our square, our big bracket, excluding A, so which is small. Okay, and in the open we have A. It is including A, and excluding B. Okay, now I'm really clear to the topic. Actually, I had a lot of confusion. So finally, the first one which I wrote was actually right. Because we can see from these conditions. Yeah, of course we'll get confused sometimes, but the right one which is going to be is that open interval. So let's let's have a look at it. Okay, so because this is gonna make this little mistake is gonna our answer is gonna be wrong, the solution is gonna be wrong. Okay, so open interval. So open interval is actually gonna be for exclude. So you can see that. So just have a look that it is saying including B but excluding A, which means that it is including B for the big brackets and including A is for the big brackets, excluding B, which is open interval, and excluding A, which is for open. So I get it that actually the open interval is going to be include, it's going to be actually exclude, yeah. Exclude, just have a look, including B, including A, okay, excluding B and excluding A. So basically, yeah, so actually excluding A. So this means that open interval actually means that these brackets, these normal brackets are for excluding, and these yeah, so I was saying that this one is going to be exclude and these big brackets are going to be for include. This is the final one and I'm 100% sure with it. Okay, so a lot of confusion is done, and so in this form it's going to be in a set builder form. How is it going to be in set builder form? So I'm going to use that X such that X first we're going to write A, okay? So just like we have to tell the value between those two numbers. I can say number elements or whatever. Okay, but it doesn't matter at all. So X such that A is okay. So it is in including. Including means including is gonna use including means close intervals. And so I'm just gonna simply write that A is smaller or equal to X, but X is smaller than B. This is finally correct and everything is gonna be right, 100%. Okay, so we have smaller or equal to X. So which means that here we have, in the first we'll have closed interval, in the end we'll have open intervals. That's it. And the figure for this is gonna be, is like, in the first we'll have fill and in the second blank. So A and B. So this is like all in the figure form, and in math form, how we're actually gonna write it. So this was all confusion and whatever it was. This was all in intervals as subsets of R. Okay, so our next question is that what do intervals provide us? They actually provide us something, a little bit of different thing. Let me tell you what they'll provide us. Yeah, so they'll provide us an alternative way of designating the subsets of sets of real number. As we've discussed that these real numbers. So these are for the real numbers, and these are basically used for just find that a value falls between two endpoints, which we have A and B, so that we can tell a value between those two numbers. Okay, yeah. So between these two elements we have, the intervals provide us an alternative way of designating the subset of set of real numbers. So that's what we discussed, that intervals are subsets of real numbers. So yeah, so that's all I think in intervals. So we're done with it, and that's all for today. And in the next video we're going to do some practice questions related to today's topic, that was subsets of sets of real number, and intervals are subsets of real number. Okay, so thanks for watching, and have a great day.